BC Calculus, Lesson 10.1, Power Series. Series gets complicated fast, so hang on tight and we'll see what we can do. What's the sum of all these numbers? If I add up what we call the partial sums, 0.5, that's the first term. Add the first two terms, 0.75. Add the first three terms, I believe you get 0.875. And we keep going on and on and on. I think we would find that it gets closer and closer and equals 1. That's a geometric series with a r value of 1/2. Because if you notice, we multiply by 1/2 to get from one to the next. Okay, what about the sum of this? It's not geometric, so what do we know? The question is, we don't know squat. And that's the kind of thing we're going to get to eventually answering. Take some time, take some effort, but we'll get there. So a lot of people think that, when you're adding up a series, it's just a binary operation. Well, 1 plus 2, and then plus 3. Well, these series are infinite, so even though you've got the associative property where you can pull any two out and add them together, a series really means the sum of all of them. What we did above is called a partial sum. So just keep those two straight. It gets confusing quickly. Here's a definition of an infinite series. Doesn't matter, just got terms. How do we get from one term to the next? We don't say. We can write it as a sum from k equals 1 to infinity of a sub k. And, we've done a little bit of series work already. So the question is, what does it mean if a series converges or diverges? It gets closer and closer to a number. That's what it means if it converges. And that is not a definition in any way, shape, or form. This is what the latter half of this unit is talking about, convergence and divergence, because it's very important, because we're going to use this to approximate numbers. Natural log of 2, how do we get that number? Well, we use an infinite series. We use a power series, we use a Maclaurin series, so on and so on. But diverges, means it doesn't converge, which is, again, not a definition. So we've got some work to do here, and I will say this. I'm on the College Board email string for people to ask questions. It's one of the most common questions. Working on a series, I don't know if it converges or diverges. So for this one, we do partial sums again. 1 minus 1 is 0, plus 1 is 1, minus 1 is 0, dot, 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 dot. This is not getting closer and closer to anything, so we say it diverges. So it's similar to a geometric proof. It's easy to prove when it diverges. I wouldn't say it's easy. It just doesn't converge. So we just say, look, it's going 1, 0, 1, 0, 1, 0. How about this one? Partial sums again. 0.3, 2 together. 0.33, 3 together. 0.333, 4 together. 0.3333, so on and so on. It would appear that this is getting closer and closer to 1/3. And again, it's a geometric series. Be careful, a lot of people say, oh, the r is 1/3. R is 1/10. Because that's what we multiply each term by to get to the next term. So, like I said, how do we know if it converges? That's a huge question. We have a little bit of a definition. The limit as k goes to infinity is 0, meaning the terms are getting smaller, smaller, smaller. So when we're adding them on, the impact becomes less and less and less. Think about that for a minute. Geometric series we've defined before. We've got a definition coming up. We take the first term, and we go 1 minus r, and that equals the sum of all the terms. This definition is so simple, but so unbelievably important, I can't put it into words. So make sure you've got that one straight. So here we go. Here's a geometric series where the r equals 1/2, and the a value is 3. Now plug in n equals 1 and make sure that's what your a1 value is. In this case it is. Look at it, we say, oh, that's to 0, that's 1, so we get 3 over 1 minus 1/2. 3 over 1/2 is 6. So if we sat down and just wrote them out, that's what we'd get. Over here, we're multiplying each one by negative 1/2. So your R value equals negative 1/2. Your A1 is obvious, is 1. So the sum of all of them is 1 over 1 minus negative 1/2, which kind of freaks people out. Well, what about the negative? Is that going to cause a problem? No. We'll just get out to 2/3 eventually. It's not unusual. It's actually fairly common. It's an alternating series. It happens all the time. And then this one, put in 0, we get A1 equals 1. R equals 3/5. Notice that this formula only works. Probably should have mentioned that earlier. If the absolute value of R is less than 1, not equal to, less than 1. So we've got 2/5, flip it, 5/2. It feels wrong to me, I'm not sure why. No, that's right. Then you look at this one, you say, okay, the R value is pi. It diverges. So geometric series are lovely. We can figure out everything we need to know. The theory's been done for us. Of course, we won't have all that many geometric in the future. But we take that simple little fact and we run with it, and we can do some amazing things. Like I just said, if the R value, and you'll say, no, that says X, and I'll say, yeah, bear with me, is less than 1, then we've got this formula. So this is our A1, and notice we're multiplying by X each time. Really looks stupid. Times X, so on and so on. So then we would say the infinite sum is A1, 1 over 1 minus the R value, X. There it is. So this series, if the X is less than 1, absolute value of X is less than 1, we'll converge to that. So if I put 0.9 in there, 1 plus 0.9 plus 0.9 squared plus 0.9 to the third, I know it'll equal 1 over 1 minus 0.9, which is 1 over 1/10, which is 10, which seems odd. Make sure you're clear on that. It's going to get really complicated really fast. Here it is again. This is our A1 value, and now we call it C0. Careful, always check that. This is being multiplied up by X again. So it's simple. So this is the sum of all of them equals C0, 1 minus X. However, we can change the X. Oh boy, that makes life complicated. And this one was centered at X equals 0. We can also center it at X equals A. And that's where you go, huh? Yeah, right. What are we multiplying each time? X equals A. What's our original value? C0, 1 minus parentheses X minus A. Which, if you think about it, it's like saying 1 plus A minus X. Exactly. We're going to do some weird math. It takes a little getting used to. So this is a power series, and I already said this. It's centered at X equals 0. And it converges on the interval. Well, didn't we just say its absolute value of X is less than 1? No. We got to write it as an interval. Negative 1, less than X, less than 1. Why do we do that? You'll see. It makes the math easier going forward. And you're going to need that because it gets complicated. So that's a lot of theory. Let's start working here. The infinite sum formula had 1 over 1 minus X. So what series represents that? Well, you should look at that and eventually say, well, that means 1 over 1 minus negative X. So the series is 1 plus negative X plus negative X squared plus negative X to the third, dot, dot, dot. I should really write this out properly, something I'm not great at. I'm not terrible at either. Sum from K equals 1. Make sure I do this right. N equals 1. To infinity of 1 times negative X to the Now notice this, negative x squared is going to just be x squared, so we can rewrite it as this. And this, of course, is the same. And I don't need the 1. That's my answer. I'm going to give you a second to let that sink in, because that's like a wow moment. And it was for me. Let's check this one out. A1 equals x, r equals negative x. I probably shouldn't write it as r. Yeah, I don't care. Let's write it. Now, a1 is x plus negative x squared. And I have to actually think about this. X times negative x squared. That seems wrong. Yeah, that's right. X times negative x plus x times negative x squared. There we go. Plus x times negative x to the third. And I'll fill this one in here in a moment. X minus x squared plus x to the third minus x to the fourth. Isn't that weird? Dot. Sum from n equals 0 to infinity. X times negative x to the n. Check that I did that right. Could probably write this a different way. Negative x to the 0 is 1. Gives me x. Negative x to the 1. Negative x times x, negative x squared. Looks good to me. If you're all freaked out, don't worry about it. It's challenging stuff, no question about it. Question, has the interval of convergence changed? To check the interval of convergence, we only put this in. Did I bother up top? Yeah, I didn't. Let's talk about the interval of convergence here. Negative 1 is less than 1. We put in negative x. Divide all through by negative x and flip it, we get negative 1 is less than x is less than 1. So it hasn't changed. Down here for this one, negative 1 is less than negative x is less than 1. Well, that's the same thing. The r value is the exact same on top and bottom, so it doesn't matter. So we get 1 less than x less than, negative 1 less than 1. Check that out if you want. You're dividing everything by negative 1. It flips the sides and moves everything around, and then you just rewrite it. I'm going to do the interval of convergence first right now. We're going 1 minus some value, so the value now is 2x. So we have negative 1 is less than 2x is less than 1. Divide by 2, divide by 2. And for the first time, the interval of convergence has changed significantly. That's a kind of a wow moment to me, like, oh boy, that's kind of a big deal. So, what about the rest of it? Well, Rx, or R I should call it, is 2x. Notice it's always 1 minus something, so we don't have to put the minus in. So, A is still 1. I should probably call it A naught. Yeah, call it A naught. Go back and fix that up above. Do I even write it here? Naughty boy. Call this one A naught. Oh, that's a lot going on. Okie dokie. So, 1 plus 2x plus 2x squared plus 2x to the third plus sum from n equals 0 to infinity of, I have to write the 1, 2x to the n. For us to write it out, and Nothing ever ceases to amaze me as much as how math can get so complicated so quickly off concepts that really aren't that big and complicated, but just zoom, off we go. So, one more. 1 over x. What the heck? It's 1 over 1 minus something equals 1 over x. Well, I need an x. If I just had a plus 1, I think that would actually work. Because the negative goes negative x. Nope, close. Now let's go 1 minus x. And that would work. A1 is still, A0 is still 1. R equals 1 minus x. Flip it around if you want. So we get 1 plus 1 minus x plus 1 minus x squared plus 1 minus x to the third. Sum from n equals 0 to infinity. Don't need the 1. 1 minus x to the n. That's just wow is all I can say. Check the interval of convergence. Negative 1 is less than something's less than 1. 1 minus x. Here I'll show you with the negative x thing where I didn't flip it, but subtract 1. We get negative 2 less than negative x less than 0 divided by negative 1. Notice that the negative flips everything, so we get 2 is greater than x is greater than 0. We like to write that from smallest to biggest. So interval of convergence has changed. Quick note on interval of convergence, if you're confused by it, don't worry about it. All it's saying is that this power series works for 1 over x when x is between 0 and 2. If it's not between 0 and 2, it probably, that's a big word, probably doesn't work. We don't have it guaranteed. We're going to spend a lot of time on that, so don't get hung up on it. Now for some calculus. You've probably been wondering where the calculus is going to pop up. Well, we know what 1 over 1 minus x is. Turns out if I take the derivative of 1 over 1 minus x, I get, the negatives cancel. I'll put them both in. Negative 1, 1 minus x squared. This is the chain rule 1, and this is the power rule 1. So I get 1 over 1 minus x squared, and that's the derivative with respect to x. So I can just take the original series, 1 plus x squared, x to the third, dot, dot, dot. Take the derivative. I get 1 plus 2x plus 3x squared plus 4x to the third plus dot, 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 dot. Sum n equals 0 to infinity of n times x to the n minus 1. Check that out. First term is 0. Weird. Second term is 1 times, yep, that works. What about interval of convergence? More later. For now, at a minimum, the same. We know the original. We took the derivative. Just assume it's the same. How about ln of 1 plus x? Well, we know that the integral, and we're doing a indefinite integral, and we're not going to worry about a c value. We don't need absolute value for this because the interval of convergence tells us it's going to be, if you put in negative 1 to 1, you're always positive. Notice it can't be 1. So what's the integral of 1 plus x squared? Oops, I just realized I screwed up. It's plus x. So now it flips everyone. I want to make sure I'm not totally screwing it up. Nope, not. Something bothering me. Nah, not a big deal. should probably pull out all those sums I've had. So integral of this, we go with x minus x squared over 2 plus x to the third over 3 minus x to the fourth over 4. And we just say that's negative 1 to the n, because it flips, x to the n plus 1 over n plus 1. Notice I didn't write it as a sum this time. That's where I just realized I've made a mistake. I should not write those as sums. So we should go back and erase those. Just yank out the sum part. Notice I also like to put the sum part in because I can check my work. But what are you going to do? Life's rough. Oh man, that's a lot of math. And there we go. Interval of convergence, same deal. For the time being, at a minimum, leave it be. How do we do? X minus x squared over 2, negative 1. Like I said, put in 0 and check it out. Negative 1, 0 by, 0 plus 1, yeah. X to the 1 is just x. Great. Looks good. And we're almost done here. I know this has been a super long video. What about 1 plus x squared? Well, if I'm not mistaken, a1 is 1 and r is negative x squared. And that would be 1 minus x squared I just find it helpful to write this differently. Wow, surprising how hard this is. Yep, there it is. I'll write this in a moment. But I found this one fascinating because this is you think about it, that should be arctangent. It's like, huh. So how the heck do we know what's going on there? Yeah, no, that's it. That works. Let's write it out. 1 minus x squared plus x to the fourth minus x to the sixth plus x to the eighth. I don't have this formula handy, so I'm going to go with my negative 1 to the n. I'm going to check that out first. The 0 is 1. To the first is negative. Good, that works. And then we've just got x squared to the n. I guess I could have just put the negative in there. That's really it. And notice it also keeps going forever and ever. Never ends. And if you notice the integral of this is arctan of x, and that would be integral x minus x to the third over 3 plus x to the fifth over 5 minus x to the seventh over 7 plus x to the 9 over 9 dot dot dot. I'm not even going to try and write that one out. But notice you could do some pretty cool things here. I mean, some really, really wow moments. It's interesting. Here's just an example. This is E, but the weird thing is the interval of convergence doesn't matter what I put in there. It's all reals, I believe, which seems very bizarre. that that would actually work. And I actually have doubts that that actually works, but that's what I'm told. Inner Convergence. So anyway, we'll come back to that more later. Well, if that's not one of the biggest lessons I've ever taught in any subject, I don't know what is. So go kick butt. And as always, happy mathing.